Okay, we're looking at an introduction to numbers, and it's going to lead to the topic on Pythagoras and surds. But the question I'm asking in this first part is, what types of numbers can you think of? And when I mean types of numbers, I don't mean an actual number like 5 or 7, but what types of numbers? So can you just brainstorm, write some answers down, and let's have a look and see what happens on the next page. Okay, so most people would have thought of whole numbers, and whole numbers are also called integers, and some people might have thought of fractions, and some people might have thought of decimals. But are there any other types of numbers that you haven't got already? Maybe you've already got it. So let's have a look. So just think, are there any other types of numbers? And when you're ready, come to the next slide. Okay, so what I'm going to do is I'm going to break up numbers into like a table. So we've got numbers, and we have real numbers. There's another set of numbers called unreal, and you don't study unreal numbers until you get to senior school and only in some of the units. So let's look at the real numbers. One group are called rational, and some of those rationals are whole numbers, like 2 or 5. And the reason they're called rational is because these could be expressed as a ratio 2/1, 5/1. Now the other part of rational numbers are the fractions and the decimals, like 1/2 and 2/3. 0.5 could be written as 1/2, and etc., etc. Okay. Now the other group of numbers that you may not have thought of or heard of are these numbers called irrational. So can you copy that down? And this is what we're going to be talking about, I think, on the next slide. So when you're ready, come across. Actually, we probably won't be talking about it quite on this video, but irrational numbers are what we're going to be looking at eventually. Okay, so all fractions can be expressed as ratios. Okay, so all fractions obviously are ratio of the numerator and the denominator. Okay, that's the ratio of the numbers. Whole numbers can be written as ratios, like for instance 5 is 5/1, like on the previous slide. And decimals can be expressed as ratios if they terminate or recur. So for instance 0.3 stops, so we call that a terminating decimal, so that's 3/10. 0.25 stops, so it's a terminating decimal, so it's 25/100, which cancels down to 1/4. And recurring decimals, such as 0.3, is the same as 1/3, which you can check on your calculator. 1/3 equals 0.3, recurring. So anything that terminates or recurs can be written as a ratio. Okay, so there's a side note. How can you express recurring decimals as fractions for the ones you don't know of by heart? Like for instance, 0.2 recurring or 0.12 recurring. Now, 0.12 recurring could also be written as a line above the 1 and the 2. Okay, so that's another way of writing things. So here's how you can turn recurring decimals into fractions. So step 1 is how many digits are repeating. So in this first one, there's one number repeating, and here there are 2 numbers repeating. So that's step 1. Step 2, for each digit that repeats, you use a 9. Okay, so we're going to have 1 9, or we'll have 2 9s. Okay, so put that number or numbers that repeat on top of how many 9s from step 2. Okay, so what that means is, let's have a look at the next slide. When you're ready, copy that down. So if you have 0.2 recurring, the number that repeats is the 2, and there's one repeating number, so it's 9, 2/9. And you can check that on your calculator. 2/9 does equal 0.2 recurring. If you've got 0.12 recurring, you put the 12 on the top, and there are 2 digits, so you put it over 99, and then that can cancel down to 4/33, and you can check that on your calculator. So steps are the number that repeats, you put on the top, and how many times it repeats, you use a 9 for each number each time. So 1 repeating number, 1 9. 2 repeating numbers, 2 9s, and then you just put the number on the top. So can you have a go at these 3 yourself, and then when you're ready, come back live. Okay, so this one is going to be 3/999, and I'm just going to check on my calculator whether that cancels down. It may not. And it does not, so that's the answer. This answer here is 25/99, and that doesn't. And this one here is 9/9 equals 1. So 0.9 recurring is the same as 1. That's an odd one, but that's what the answer is. I think that might be it for this slide. Okay, no. So I've got one more slide. So what about when you got 1.2 recurring, which is 1.2222 all the way through? So what we do is we break up the 1 away from the 0.2 recurring. So this is the whole number, okay? And then this is the recurring decimal. Okay, so then this 0.29 recurring is, you put the 2 over 19, and then that cancels down to 11 on 9. So have a go at these two yourself, and then when you're ready, come back live. Okay, so we've got 3 plus 5 over 9, and 9 3s are 27, plus 5, 27 equals 32 over 9. This one here is 1 plus 92 over 99. 99 times 1 is 99, so 183 over 99, and 183, clear 183 over 99, and that cancels down to 61 over 33. Okay, so you can check your answer, see if that does equal as a decimal, and it would equal. Okay, that's the end of the first slide. So there aren't any exercises.